Hello guys, our lesson for today is parity of a function. In this lesson, we study parity of a function, which tells us whether a function is even or odd and how to determine this using algebraic testing and graphical interpretation. Parity of a function. Imagine folding the graph of a function along the y-axis, as you can see in figure 1. Does it match perfectly? If the left side matches the right side perfectly when you fold this paper, this means that the graph has the y-axis as an axis of symmetry. Another thing is rotating the graph 180 degrees around the origin. Imagine that this is the origin. If you rotate this graph around the origin for 180 degrees, if the left side overlaps the right side, this means that the graph has the origin as its center of symmetry. These simple symmetries help us classify functions as even or odd. The idea is called the parity of the function. Then, what do we mean by the parity of a function? It is the attribute of the function to be even, odd, or neither. Some graphs are neither symmetric with respect to the y-axis nor symmetric with respect to the origin. Now we will start by even functions. But before we start by even functions, let us remember or recall what do we mean by axis of symmetry of a graph C of a function, C of a function f defined over an interval I. Its domain means its domain is I. X equals A is an axis of symmetry of graph C if it satisfies f of A minus x is equal to f of A plus x for every x belongs to I. Now, what if A is 0? Then the axis of symmetry is x equals 0. X equals 0 is the equation of what line? It is the equation of the y-axis. Now here, the line of symmetry is the y-axis. Let's see how the equation will look like. A is 0, so you need to verify that f of minus x equals to f of x for every x in I. In this case, if the function satisfies this equation for every x in I, then the y-axis is an axis of symmetry of the graph C of f, and f is an even function. F is an even function. Now the simplest example about an even function is f of x equals x squared. If f of x is equals to x squared, then f of minus x is equal to negative x all squared equals x squared, which is f of x, and so y equals x squared is an even function. As you can see in the graph here, the y-axis is an axis of symmetry for the figure. The figure folds perfectly over the y-axis. So as for the definition of even functions, let f be a function defined over an interval I subset in R, and C is its representative curve. Function f that changes neither the sign nor the absolute value when the sign of x changes. So f of x is the same as f of negative x, where x and negative x are in the domain of definition of f, is called an even function. Therefore, the graph of an even function is symmetrical with respect to the y-axis. And now, after we have discussed even functions, we will move to odd functions. Also, we will recall here the concept of center of symmetry. When do we say that a point H with abscissa A, ordinate B, is the center of symmetry of a graph of C? If sure C graph of f defined over interval I. Its domain is I. If for every x in this domain you have f of a minus x plus f of a plus x is equal to 2b. Now here in this case we will take the point H to be the origin O, 0, 0. So A is 0 and B is 0. When does the origin become the center of symmetry? Let's check the equation. A is 0, so f of negative x plus f of x is equal to 2 times 0 to 0. Okay, so f of negative x is equal to minus f of x, or in other words, f of x is equal to minus f of negative x. In this case, we will say that the origin O (0, 0) is the center of symmetry of the graph C, and the function the function f here is said to be odd function. The most primitive example about odd functions is f of x equals to x cubed. Let's calculate f of negative x. It is minus x all power 3, since the exponent is odd, so the answer is minus x cubed, which is minus f of x, and the function x cubed f of x equals x cubed is considered to be odd. So as for the definition of odd functions, if f is a function defined over an interval I subset in R, and C is its representative curve a function f that changes sign this time, but not absolute value. When the sign of the independent variable is changed, is odd. So if f of x is equal to minus f of negative x, where x and negative x sure belongs to the domain of f, then the graph is an odd function and it is symmetrical with respect to the origin O.